The top view of a line capital PQ is 75 mm long, measures 50 mm. The NP is 30 mm in front of VP and 15 mm above HP. The NQ, capital Q, is 15 mm in front of VP and above HP. Draw the projections of the line and find its inclination with HP and VP. Find the length of front view and distance between end projectors. So here, it says the NP is 30 mm in front of VP and 15 mm above HP. So when you look from the front view, we can see the distance. The NP is 15 mm above HP. The distance is seen in the vertical plane, and you can see that image, which is P dash, which is 15 mm above HP. So you mark this point as P dash. And the NQ is 15 mm in front of VP. And the NQ is 15 mm in front of VP and above HP. So when you look from the top view, we can see the distance in front of VP by 15 mm. So you will going to get the locus of BQ in the top view. And above HP, of course, he has not given any distance with respect to above HP. So we will not be able to find the locus of Q at this juncture. Draw the projections of the line. So he says the top view of a line capital PQ is 75 mm, measures 50 mm. So that means he has given the top view distance and also the true length 75 mm. But also we know the locus of Q in the top view. So that means the endpoint of the top view line of Q and also the true length of the Q, will also lie on the same locus. So with P as center, you take the radius of 50 mm and cut an arc on the locus of Q in the top view. So to get the top view distance and join PQ. Similarly, you know 75 mm long. So with P as center, cut an arc on this so that you will going to get the locus of Q. Cut it on locus of Q to get Q2. So join P and Q2. So you will going to get the true length. So once you know this true length, so that means the true length in the horizontal plane means it is above HP by 15 mm, P, capital P, and capital Q2 is also above HP by 15 mm. So now we got this line. Now what we need to find? We need to find out the locus of Q in the front view. So to find the locus of Q in the front view, but we know, and also since we know the top view, the front view point should lie on the same end projector line. So when you project this Q here to the XY line, and from here you draw a vertical projector in the front view. So you will go to get this. But we know that front view point should lie on this end projector line. So to do that, you have to take the top view now. When you want to take the top view, so that means we have the true length in the horizontal plane, which is P, capital P, and capital Q2. When you look from the front view, Q2 dash is also above HP by 15 mm. Now we got the front view. But the front view point of Q2 should lie on this end projector. With P dash as center, taking the radius of Q2 dash, you draw a arc such that it will go into cuts on this end projector line. So that means what you are trying to do is with P as center, taking the radius of PQ2, you rotate this PQ2 line such that it will go to falls on the end projector of this capital Q. So now we got this point. So once you get this point, so image will going to be from Q2 dash. It is rotated such that it will going to cut the end projector point at this Q dash. Then join P dash Q dash with a dark line. So now we got the locus of Q in the front view. Once you get the locus of Q in the front view, now we need to find out the true length in the vertical plane. So to find the true length in the vertical plane, we have to make the line parallel to VP. So we know that small p, capital P and Q, we got the point. So with P as center, taking the radius of capital PQ, you rotate it, make it parallel to VP. So once you make it parallel to VP, so we will going to get the true length in VP. So you draw a projector from here on to the locus of Q so that you are going to get the Q1 dash. then join P dash Q1 dash with a line. Then, so when you are rotating that, what we are trying to do is in the horizontal plane with P as center, taking the radius of PQ, you rotate it and make it P and Q1. Both are in front of VP by 30 mm. So now the line is parallel to VP. So you are getting the true length in the vertical plane. When you look from the front view, PQ1 will be the line which is parallel to VP. When it is projected, it will fall on the vertical plane, so that you are going to get this point Q1 dash. So this is how we will be able to analyze this problem in the 3 dimension. Now we go for the stepwise. So in this we have the top view line and also the true length. So that means we have the true length line here, which is on the horizontal plane. You rotate such that Q2 is rotated such that it will going to be on this end projector on this line, so that it will going to cut this point. So now we got this in space, which is PQ. So now we got the locus of Q in the front view when you are projecting it. And when it is looks on the front view, that image will going to fall here, which will be P dash Q dash. So that is what we have shown here. We are considering, so we know the end projector distance because you know the top view. The front view point of PQ should lie on this end projector. So for that, we have to take the top view true length. Once you take the top view true length, when it is projected in the front view, so we know that this is the true length in the horizontal plane. So that means both P dash and Q2 dash should be above HP by 15 mm. So that is the reason why we are projecting this Q2 also above HP by 15 mm. So with P dash as center, Q2 dash as the radius, you rotate it such that this will going to fall on the end projector of Q, such that you will going to get the Q dash here, then join P dash Q dash with a dark line. So you have the locus of Q now in the front view. Similarly, if you are considering, so I want to find out what will going to be the true length in the vertical plane. So to do that, to take this PQ, make that PQ line, capital PQ line, make it rotate to parallel to VP. Once you make that, both P and Q1 should be in front of VP by 30 mm, so that PQ1 will be in front of VP by 30 mm. So that when you look from the front view, you are going to get that line as the true length line, which is P dash Q1 dash. Now here, what we are doing in the orthographic view, so we are rotating so that the top view line of this is rotated to make it parallel. So which is the top view line? PQ. You make PQ, make it parallel to VP. So when you are rotating that capital PQ, which is in space, when it make it to rotate parallel to VP, so that image in the top view is rotated. So that is the reason why we are showing this image, because this is rotated in space. So when you look from the top view, that image will go to be rotated in the horizontal plane. So that is the one which we are showing here, with P as center, taking the radius of PQ, rotate it and make it parallel to VP. So PQ1 is parallel to VP. So you are getting the true length in the vertical plane. So from Q1, you draw a vertical projector to the locus of Q, so that it will going to get this point Q1 dash. Then join P dash Q1 dash, you are going to get the true length in the vertical plane. Now we will go to, this is how we will be able to analyze the problem in 3 dimension. Now we will going to solve the problem using the sketch. Here, first we are going to consider the XY line and mark XY and VP HP as shown. You know that NP is 30 mm in front of VP and 15 mm above HP. So from XY line, you measure 15 mm above XY line and draw a horizontal line. Similarly, 15 mm, 30 mm in front of VP, from XY line, you measure 30 mm below the XY line and draw a horizontal line. And consider any point, and from here you draw a vertical projector such that it is going to cut both the parallel lines, so that you are going to get this point P dash here in the front view and small p in the top view. And you also know that NQ is 15 mm in front of VP. So from here you measure 15 mm and draw a horizontal dash dot line with a thin line. So it is in front of VP, so obviously it will be below XY line. Now you mark this as the locus of Q. And you know that the top view of a line capital PQ is 75 mm long, measures 50 mm. So by using the compass, you measure a distance of 50 mm with P as center, cut an arc on the locus of Q, so that you are going to get this point. Here you mark this point as small q. And similarly, with P as center, taking the radius of 75 by using the compass. Again, you cut an arc on the locus of Q in the top view, so that you will going to get this point Q2, small q2. Mark these 2 points. We know that once we have so join PQ with a dark line and PQ2 with a little bit darker than the XY line. Then we know that the front view point of this Q dash should lie on this end projector, which is Q end projector in the front view. But we know the top view because we don't have the true line, we don't have the locus of Q in the front view. So first we need to find out the locus of Q. So to do that, since we want to find out the front view point, so obviously you have to take the true length in the top view. We know that this is the true length in the horizontal plane, means that line in the front view should be parallel to XY line. So that means P dash is above HP by 15 mm. Then Q2 dash should also be above HP by 15 mm. So from Q2, you draw a vertical projector to the locus of P dash or locus of P in the front view, and you mark this point as Q2 dash, such that both P dash and Q2 dash are above HP by 15 mm. So now we got P dash Q2 dash is the line which is the front view line. But actually the Q2 dash will not going to be on this end projector. Instead, it will be on the end projector of Q, which is projected from the top view point of Q. Then with P dash as center, by taking the radius of P dash Q2 dash using the compass, you draw a smooth thin arc, such that it will go to cut the end projector line at this point, and you mark this point as Q dash and join P dash Q dash with a dark line. And once you get P dash Q dash, then through Q dash you draw a horizontal dash dot line, so which will going to be the locus line, and you mark this point as locus of Q in the front view. Now to find out the true length in the vertical plane, so you have to take the line which is parallel, we have to make that line parallel to VP. So we have to consider since we have to find out the true length in the vertical plane, you have to take the line which is inclined to VP and make that line parallel to VP. So with P as center, since we want to find out the front view true length, so you have to take the top view line. So with P as center, taking the radius of PQ by using the compass, draw a smooth arc such that both small p and small q1 should be in front of VP by 30 mm. So and you mark this point as small q1. So now PQ1 will be in front of VP by 30 mm. So now the line is parallel to VP. Once the line is parallel to VP, so you're going to get the true length in the vertical plane. So from Q1 dash, you draw a vertical projector with a thin line such that it will go to cut the locus of Q in the front view. Once you get this point, you know this is top view Q1, then this point will be Q1 dash, small Q1 dash. Then mark small Q1 dash, and since this line is parallel to VP or parallel to XY line in the front top view, so obviously that P dash Q1 dash should be the true length. So you mark this point as small capital P in bracket and small capital Q in bracket. Join P dash Q1 dash with little bit thicker than the XY line. So then find the length of front view. So since we need to find out the length of the front view, by using the scale, you measure the distance from P dash to Q dash. So P dash Q dash will be 74 mm, and when you are drawing it in computer, it will be 73.48 mm. Then join P dash Q1 dash with a little bit thicker than the XY line. So then mark this apparent inclination with respect to HP as theta, true inclination with respect to HP as alpha, apparent inclination with respect to VP is beta, true inclination with respect to VP, which is phi. So by using the protractor with P dash as center with respect to the horizontal line, you measure an angle apparent inclination which is alpha, which will be 49.53 degrees when you are doing it in computer. When you are doing it in manual, it will be 50 degrees. Similarly, with the same point, you measure an angle which is true inclination with respect to HP, which is theta, which will be 48 degrees when you are doing it in manual. When you are doing it in computer, it will be 48.19 degrees. Similarly, by using the protractor with P as center with respect to the horizontal line, you measure the apparent inclination which is phi, which will be equal to 12 degrees. When you are doing it in computer, when you are doing it in manual, when you are doing it in computer, it will be 11.54. And similarly, with apparent inclination with respect to VP, which is beta, which will be 17.46 when you are doing it in computer. When you are doing it in manual, it will be 18 degrees. So this is how you will, and also you measure the distance between the end projector. So by using the scale, you measure the distance between these two, that is the end projectors of P and also the end projector of Q. So here the D will be 47.70 when you are doing it in computer, but when you are doing it in manual, it will be 48 mm. So this is how you will, and also you measure the front view distance, which is P dash Q dash, which is 73.48 when you are doing it in computer. When you are doing it in manual by using the scale, you measure the distance, which will be 74 mm. So this is how you will be able to solve this by using the sketchbook.